Okay, so now we're going through the tests which had the heading fuses and earthing. In question 1, what is the symbol for a fuse, 1A? And the answer is something which I think I might have got wrong with you guys before. It's a resistor with a line through. For some reason I might have said earlier that it's a resistor with a cross in it. I can't see any evidence in any of the textbooks that this one here that I mentioned to you is correct. All I see is the one that I've just mentioned as the answer. So I might have been bad and given you a wrong thing. I somehow doubt it. I think they are. There is an alternative, but don't bank on it. Your textbook says it's a line all the way through a resistor. So this one here is the right answer. For part B, double insulation, 2 squares, one inside the other, like so. Not very well drawn in my case, but no doubt yours is substantially better. And for part C, an earth connection is effectively a wire connected to those parallel lines getting smaller and smaller, as shown. For question 2, what is the purpose of a fuse? I think I need another slide for that one. The purpose of a fuse is effectively to prevent houses burning down in this way. A live wire will have a fuse in it to protect the wires which are in the walls of houses, because these wires that I'm indicating now are thin. They're only rated at whatever current is appropriate for this device here, so that if too much current is in the wires that I've scribbled along, they will get too hot, they will burn, and they will cause the house to burn down. The fuse, which I'm focusing your attention on now, that doesn't matter if that burns out, because if it does burn, it's a very small device, burns quickly and breaks the circuit, so everything is safe. So it protects property from burning down, and can be used, I suppose, in conjunction with the earth, which is question number 3, which I'm just about to get on to now. So for question number 3, why is an earth connection necessary when using electrical appliances made of metal? And the answer is, if there is your metal case, which is possibly going to be connected to the live wire, which could be dangerous for anybody touching it, you want to prevent that danger from killing anybody who is touching that metal case. And essentially how that works is as follows. You want a wire connected to earth, which is also connected to the metal case. You want that resistance, the resistance of that region that I'm circling now, to be much lower than the resistance via an individual who might be standing on the ground and who has, not that they'll have a connection via the head, I suppose, but you want that connection that I've ringed up there to be a lower resistance than the resistance I'm now ringing, so that of course all the charges are going to go through that line and make the fuse burn out to cause everything to be safe, not this line here through the individual. So really it's like having 2 resistors, R1 and R2, in parallel. You want R1 to be very low because you hope R2 will be bigger, and so therefore will not have so much charge flow in it to kill the individual who is making that connection. So that's question 3, whatever you've written for it. My answer is, of course, worth about 5 out of 3. Now for question 4, it says, draw a circuit containing a fuse, a 230 volt alternating supply and a 46 ohm load. Label the live and neutral wires. Here goes. So here's a circuit with a connection, and there's the fuse with a line through it. 46 ohms there, and the neutral wire, which is connected to the other side of the 46, live on the top, neutral on the bottom, and the 240 volts, or is it 230? 230 volts alternating supply is across the live and the neutral. Label the live and neutral wires I have. Where would the earth connection be made? Answer, it's made to the metal case that I'm drawing around that. There it is, to the metal case around your washing machine or whatever it is. And what value fuse would be required? 3, 5 or 13 amps. Answer to that is as follows, similar to what I think you've just been doing as regards fuses. We need to work out the current in the circuit as being a ratio of the PD across the resistor divided by the resistance itself. And that will give you a value of 230 divided by 46. That's the actual value of the current in the wires, and that to me is 5 amps. So the fuse you would use is not 3 amps, not 5 amps, but 13 amps. That's the answer, 13 amps, to protect the wires from burning out and causing a fire and causing misery all round, etc., etc. I have to stop now, Mr. Whitcomb has come in. So don't forget then that the actual value of the current that you calculate, that 5 amp value, is not necessarily the value of the fuse to use, because you want the fuse to burn out at the value that is stated on it. If it burnt out at 5 amps, it would never make the equipment, your 46 ohm thing, it would never make it work properly. And there you are, and that's the test gone through.